In this video, we will deconstruct Standard 4 NF7 of the Grade 4 Georgia Standards of Excellence for Mathematics. This standard focuses on comparing two decimal numbers to the hundredths position. Standard 4 NF7 requires students to compare two decimals to hundredths by reasoning about their size. This standard also necessitates that students recognize that comparisons are valid only when two decimals refer to the same whole. Students record the results of comparisons with symbols greater than, equal to, or less than, and justify the conclusions. For example, looking at the two models, students reason that 62 hundredths and 27 hundredths are valid comparisons because the wholes are the same size. Additionally, students determine that 62 hundredths is greater than 27 hundredths because the area that represents 62 hundredths is greater than the area that represents 27 hundredths. Grade 4 is the first time that students are introduced to decimal concepts, and standards 4 NF5, 4 NF6, and 4 NF7 lay the foundation for performing operations with decimals in grades 5 and 6. In Grade 4, students investigate the relationship between fractions and decimals, read, write, and represent decimals, and compare two decimals to the hundredths place value position. In Grade 5, students read, write, and compare decimals to the thousandths place, use place value understanding to round decimals to the hundredths position, and use concrete models and drawings to add, subtract, multiply, and divide decimals to the hundredths place value position and relate the strategy to a written method. In Grade 6, students fluently use the standard algorithm to perform all operations with multi-digit decimals. Standard 4 NF7 calls for students to use visual models such as area models, decimal grids, decimal circles, or number lines to compare decimals. These experiences support students in developing the understanding that comparisons between decimals are only valid when the whole is the same for both cases. It is important that students have concrete experiences to represent the magnitude of decimal numbers. The first task we will look at emphasizes area models and decimal number lines to support conceptual understanding of decimal magnitude and comparisons. In Grade 4, students use area models, such as those shown, to represent and compare decimal numbers. The area model on the left represents 9/10ths, and the area model on the right represents 90 hundredths. Because the same amount of area is shaded on both models, 9/10ths is equal to 90 hundredths. Students might also use a number line to compare decimal numbers. Let's compare the numbers 8 hundredths and 8/10ths. The arrows show the location of both decimal numbers on the number line. Students often have a misconception that 8 hundredths is greater than 8/10ths because 8 hundredths has more digits. Students need to understand that they must look at the place value digits when comparing two decimals. A number line can support students in alleviating decimal misunderstandings. By locating both decimals on the number line, students can determine that 8 hundredths is less than 8/10ths. Let's watch as a student reasons about decimals in the double number line decimal scaffolding task.
How did you know where to put that first decimal grid right there?
So when you have a number line, I had to fill out hundredths, and there's 100 hundredths in one, and every 10 of them is 1/10th of the way there. That's these big marks. So I can count by 1/10th or 10 hundredths, 2/10ths or 20 hundredths, and since I have 0.23, I have to go 3 hundredths, which is 1, 2, 3. So that's why I have to put it right here.
So are you saying that 0.23 is less than 0.3?
Yes.
How do you know that?
So on the number line, 0.23 is right here, and 0.3 is right here. And when a number is the leftmost to another number, that means that it's less than that other number on a number.
So, but 0.23 has 1, 2, 3 digits in it,
Yeah.
and 0.3 only has 2 digits in it.
Mm-hmm.
So how does 0.3 that only has 2 digits, how is it bigger than 0.23 which has 3 digits?
Because each digit represents a different place. This is 3 hundredths, which is way less than 3/10ths. So 0.23 is less than 3/10ths.
Are any of these values equivalent?
Yes.
And how do you know?
Right here, 0.5 and 0.50.
Explain. How do you know they're equivalent?
This is 0.5, which is 5 tenths, and this is 0.50, which is 50 hundredths. There's 5 10 hundredths in this one, which is equal to 5 tenths, and this is also 5 tenths, so they're equal.
Now let's look at some other concrete and visual models that students may use to compare decimal numbers. Let's start by using base 10 blocks to compare 2 and 52 hundredths and 2 and 6 tenths. In this example, each flat represents one whole, each rod represents 1 tenth, and each cube represents 1 hundredth. 2 and 52 hundredths can be represented as 2 wholes, 5 tenths rods, and 2 hundredths cubes. 2 and 6 tenths can be represented as 2 wholes and 6 tenths rods. Looking at the base 10 blocks, we can see that 2 and 6 tenths is 8 hundredths greater than 2 and 52 hundredths. Another concrete model that students may use to represent and compare decimal numbers is place value discs. On the left, the place value discs represent 1 and 6 hundredths, since 10 1/10 is equal to 1 whole, and 6 times 1 hundredth is equal to 6 hundredths. On the right, the place value discs show 10 100ths, which is equal to 1 tenth. By looking at the models, students can conclude that 1 and 6 hundredths is greater than 1 tenth. Another concrete manipulative that students may use to represent and compare decimal numbers is dimes and pennies. On the left, the coins represent 32 hundredths or 32 cents. On the right, the coins represent 45 hundredths or 45 cents. The model shows that 32 cents is less than 45 cents. Another visual model that students might use to compare decimal fractions is a hundredths disc. The red hundredths disc is labeled in tenths. Notice that the red shaded area extends about a hundredth past the 6/10 mark, so the red shaded area represents 61 hundredths. The blue hundredths disc is labeled in hundredths, and the blue shaded area represents 39 hundredths. The area of the red shaded part is greater than the area of the blue shaded part, so 61 hundredths is greater than 39 hundredths. As students build their understanding of decimal numbers, they rely on place value understanding to compare two numbers. Looking at the place value chart, we see that both numbers have a 3 in the ones position. If we look at the tenths position, we notice that 3 and 14 hundredths has 1 tenth, and 3 and 9 tenths has 9 tenths. Since 1 tenth is less than 9 tenths, 3 and 14 hundredths is less than 3 and 9 tenths. Another task that can support students with Standard 4 NF7 is decimal lineup. This task requires students to order decimal numbers and locate them on a number line. Let's watch as some students work through this task. What number will come after 1 and 2 tenths, and how do you know?
1 and 6 tenths, since 2 and 3 tenths is bigger than 1 and 6 tenths by the whole number. So this one right here is 1 and 6 tenths.
What number will come next?
2 and 3 tenths, because 2 is not greater than 3. Then you got the last one, 3 and 7 tenths.
How did you know where to place 3.7 on the number line?
Well, I knew how to place 3.7 because 3.7 equals 3 wholes and 7 tenths. So you count 3 wholes, 1, 2, 3, and then 7 tenths. 1, 2, 3, 4, 5, 6, 7.
Okay, is there another way that you could have determined the location of 3.7? Let's say if you knew where 4 was, how could you figure out where 3.7 is from 4?
Well, 3.7 is 3 tenths away from 4, so I could count 3 tenths backwards. 1 tenth, 2 tenths, 3 tenths, and gotten 3.7.
Okay, great.
After students have ample experiences with decimal concepts, they begin to solve problems with decimals, which applies to Standard 4 MD2. Let's look at an example. Valerie and her friends are running in a race. The table lists the running distances for each person. Valerie ran 4 and 32 hundredths kilometers, Maya ran 4 and 4 tenths kilometers, and Ayana ran 4 and 5 hundredths kilometers. Who ran the greatest distance? Justify your answer. Let's start by listing each distance in a place value chart. Looking at the place value chart, we see that all three numbers have a 4 in the ones position. If we look at the tenths position, we notice that 4 and 32 hundredths has 3 tenths, 4 and 4 tenths has 4 tenths, and 4 and 5 hundredths has 0 tenths. Since 4 tenths is the greatest, 4 and 4 tenths is the greatest number. So Maya ran the greatest distance. Valerie ran the second greatest distance, and Ayana ran the least distance. For additional information about Standard 4MD2, check out the 4MD2 video and resources. MathLearningCenter.Org offers free digital web apps that provide students with visual models that support with conceptual understanding. Let's take a look at the Fractions app and the Numberline app. In the Fractions app, students and teachers can use the fraction bar tool to create decimal grids such as those shown on the screen. The text tool feature can be used to label the grids and indicate greater than, less than, or equal to comparisons. The first decimal grid represents 34 hundredths and the second grid represents 4 tenths. Since the amount of area shaded on the 34 hundredths grid is less than the amount of area shaded on the 4 tenths grid, 34 hundredths is less than 4 tenths. Now let's take a look at the Numberline app. The Numberline app allows 4th grade students and teachers to create a number line that is labeled in tenths or hundredths. The custom tick mark feature allows for the insertion of additional numbers. Let's suppose that we want to compare 2 and 35 hundredths and 2 and 13 hundredths. I can use the custom tick mark tool to find and label both decimal numbers on the number line. 2 and 35 hundredths is greater than 2 and 13 hundredths. For additional information about the Georgia Standards of Excellence, please visit GeorgiaStandards.Org.